Welcome to problem 3.39 on the bottom of page 135. In this particular case, we're asked to calculate the mean, variance, standard deviation, and then we're going to deal with something new related to the empirical rule, which you can find on page 134 and 135 of your textbook. Basically, that means finding the area underneath the curve. And so there's an empirical rule, which is related to the normal distribution, which if you've listened to the lecture, you are familiar with regards to the fact that if the data is normally distributed, that 68% of the data will be plus or minus one standard deviation from the mean. That if the data is normally distributed, 2 standard deviations will represent 95% of the area underneath the curve, and 3 is 99.7. It's actually 7.3, but that's if it's normally distributed. If it's not normally distributed, you can use Chebyshev's rule, which is something that just mentioned very briefly. We're not really going to spend a lot of time on it, on Chebyshev, if at all, in this particular course. So focus on the empirical rule, which we'll use much later in the course or we'll actually use many times later in the course for determining the areas. We'll use this with confidence intervals for the lower and upper limits. So reading the data, you've got the mean, the variance, and the standard deviation. I'm going to show you in the Excel video how to calculate that. And then you take the mean, you subtract one standard deviation, which is 279.3546, and you get negative 2.86 for the lower part of one standard deviation, and you add the 279 to the 276, and you get the upper. So what this represents is 68% of the data is between negative 2.86 and positive 555.4. And then the same thing, 2 standard deviations is negative 282 to positive 835. 3 standard deviations is negative 561 to positive 1114. And when you go to test this, if you want to see looking at the numbers, you count them. You can do this in various ways, but you look at it and you say, well, 45 out of 51 of the data points were within one standard deviation, the negative 2.86 to the 555.84. And so that's actually 88%. So it's even more than the 68. You do the same thing for, and there's 48 states. So you're doing the same thing, but testing for the 95. And in this particular case, 48 out of 51 is 94. So, you know, because your distribution is not perfectly normal. And then 49 is 96.08. So what this represents is you actually have 88% of the data is within the first standard deviation, plus or minus. It's close. It's 94.12, not 95. So it's a little low for 2 standard deviations. And then 96.08 is a little low for 99.7. So what this would represent is you actually have a data set that is flatter, or it's wider, and it's fairly peaked. So what you can imagine is a mountain or whatever that's wide at the base, and then it starts to go up, and once it starts to go up, it goes up very quickly. So if that helps, and I'll show you how to do this using Excel.